Hello and welcome to part 4 of the Git and GitHub tutorial series. Here are the subjects we will be covering for today. The first topic will be merge conflicts. We briefly went over this topic in part 3 of the video tutorial series, and I skipped over the topic completely when we were talking about the GitHub Windows GUI. Merge conflicts is a very in-depth topic, and I did not want to try to cover it in part 3 of our video series. In Git, there are two distinct ways to handle merge conflicts. You can either use git merge or git rebase. We will cover both in the demo. Lastly, we will talk about how you can avoid merge conflicts with a little planning and discipline. The second topic will be about tagging. Tagging is very similar to how a commit works. The most common use for a tag is to bookmark a milestone or event in your commit history. An example of that would be you would tag every single time your software is ready to be released and shipped out to your customers. The last topic is about viewing and reverting back to the previous commit. There is also two ways to do a revert back to the previous commit. It's important to know which one to use depending on the circumstances. Lastly, I will give you my final thoughts on this topic, as this will be the last planned video release for this series. Let's jump into our first topic, which is merge conflicts. As you can see right now, we have two instances running. We have a Windows 7 instance and we have a Linux Ubuntu instance. And what we're going to simulate with these is we're going to have a Windows user using the GitHub Windows client, and then we're going to have an Ubuntu user, and they're going to use the Git bash or the command line version of the Git client. So let's get started with a recap on why merge conflicts happen. So I'm just going to go over to my Windows client, and I'm going to go ahead and start GitHub, and I'm also going to start Eclipse. So as you can see, the GitHub GUI is already booted up, and then we'll wait for our IDE or development environment to boot up. So right away I'm going to go ahead and create a new web project. So I'm going to create a dynamic web project, and then I'm going to name it part4.demo. And then in the web contents folder, I'm going to go ahead and put in a new HTML file, and that's what we will be modifying for the demo today. And that's right there good enough for our first initial repository. So I'm going to go ahead and find this project in my directories, and there it is, part4.demo, and I'm just going to go ahead and drop it into the GitHub GUI, and then I'm going to say part4demo, and I'm going to go ahead and select this. So I'm just going to go right away, push it up to GitHub, the repository, and then I can say create. So there it is right there, and right away you'll notice that the git attributes and git ignore are automatically created for me because I'm using the GitHub Windows client. And just remember that the git ignore has a lot of things already put in for Eclipse, so it's only going to save what I modify in the web contents. So I'm just going to do my first commit. And then I'll go ahead and push it up to GitHub. Just wait for that to finish up. Okay, the first commit is now in GitHub. So let's go ahead and go over to our Ubuntu user, our Linux user, and he wants a copy of that project too. So let's go ahead and open up the command line, open up Eclipse, and also open up a web browser. So from our web browser, we're going to go ahead and go out to GitHub. We are already logged in, so we can just scroll down, and then we can go to part4.demo, that repository. And what we're looking for here is, again, the SSH URL. So we'll go ahead and copy that. We'll go into our command line, and we're going to type in ls, and we're going to find a place where we want to put this project. So I want to put it into my Oracle, ls again, and I want to put it into JProject. So cd jprojects, and this is where I want my project to stay. So if we look at it through the directory folders, it would be Oracle jprojects, and I already have a project in here from a previous demo. So let's go ahead and do a git clone, and then we'll just copy in that URL link, and that will download to my box. So as you can see, part4.demo is now on my box, and you'll notice that only web contents came down because, again, we're only version controlling files that we can control, not any of the Eclipse files. So in order to get it into our Eclipse, what we're going to have to do is we're going to have to create a new dynamic web project, and we're going to name it the same thing as that web folder. So part4.demo, and then we'll hit finish. And when you come in here, you created all the Eclipse stuff, which is this, but in the web contents folder, you'll notice our index.html is where it's supposed to be. So let's go ahead and go back and look at part4.demo, and you'll notice that here's our web contents folder that came down from GitHub, and the other two folders got built when we created it in our IDE. So let's go ahead and start with our first commit. So let's come in here into our Windows client and then do, say, demo 1. Right? Then we can click on this button and do our first commit. So, well, technically our second commit, but this is our first content commit. So we'll say commit 1 first content, and we'll go ahead and save that, and we'll sync that up to GitHub. We'll wait for that to finish up. So at this point, our demo 1 is now up onto the Git repository. So if our second user, the Linux user, if he actually modified the same area, say he did demo 2 and he saved that, and he went ahead, well, let's go ahead and go into our project folder. So let's go ahead and cd into part4.demo, and then he did a git add dot, and then he did a git commit -m, and so he did a second content commit, and now the same area has been modified two different ways from two different users. So our Windows user has modified it using demo 1, and our Linux user has modified it using the word demo 2. So before we can actually push up with our Linux users, what we need to do is we need to tell it where the remote repository is, because that doesn't come down with a clone. So what we need to do is we need to say git remote add, and we're going to name it GitHub because that's where our remote repository is, and then we can copy that same link in again. So now if we did a git, it is highly recommended, in fact you have to do it, to do a git pull GitHub master. So you always want to pull from the repository first to make sure that you have the newest changes down in your local box. But say you skip that step and you just did a push, so you just want to push your code up. If you were to do that, and if your repository isn't the latest, it will actually mark you down as rejected. It would say, it's basically telling you that there is a newer project history up there, and you need to pull it down before you can actually push yours up. So that's what we're going to do. So we're going to do a git pull GitHub master. So at that point, it tells us there's a conflict, and what Git does is that it doesn't try to handle it for you. It says you're going to need to handle it yourself, because I don't know what goes in what order, because you're both modifying the same area. So if you come in here, it'll modify it. So let me move this up. So it'll say, okay, demo 2 is what you have, But demo 1 is what I show in my remote repository. Here are the two changes. Please resolve them. So I said, you know what? Get with the other developer, and we know exactly how this goes. This is what we want it to look like. And we save that, and that's what we want it to look like. So what we would do then is we would do a git add dot git commit dash m, and we would say resolved merge conflict. And now what we can do is, if you went ahead and do another poll, so you did another poll just to make sure that you don't have any more new changes that came in. Obviously, with a small demo like this, you will never have another one that we don't know about. But let's just do it just for demo sakes. So we can do git pull GitHub master. It'll tell us that we're already up to date. So now we can do a git push GitHub master. And now we'll actually upload our changes to the remote repository, which is GitHub. So if we went ahead and go back to our Windows client, and we actually have to back out and then go back in so that we can actually have this button refresh. If we do a sync again, what it's going to do is it's going to go out to the remote repository. It's going to see my changes and how I went ahead and resolved it, and that would be another commit. So in here, you will see now both demo 1 and demo 2 in the correct order, because I put it in the correct order during my resolve merge or resolve conflict commit. So that is a demo of how Git Bash, or the command line client, handles a merge conflict. So let's look at the reverse. Let's look at how the Windows GUI will handle a merge conflict, and it does handle a little bit differently. So let's go ahead and go back to our Linux user, and this time he will be the first one to do the commit. So Windows 1. So that will be the change that he put in. And instead of doing git add dot and then doing git commit dash m all the time, what we're going to do is we're going to go ahead and combine both of those commands. So we can say git commit, and we're going to say dash a and then dash m. So the dash a is add everything to the staging area, and the dash m is for the message. So we can say Windows 1 content, and then we can do a git. We'll go ahead and just do it correctly. We'll do a git pull GitHub master. Even though we do know that we are up to date, we'll just go ahead and do it, and then get a git push GitHub master. So now we're pushing up to the Git repository. So at the same time, we're going to be modifying the same area again. So we're going to do Windows 2, and we're going to go ahead and save that. So Windows 2 content Windows 2, and we'll do a commit on that, and then this time we'll do a sync up. So the Windows GUI client sees that there is a conflict, and what it's telling you to do is that it doesn't know how to handle it through the GUI client. So it's asking you to go to the command shell and resolve it yourself. And what's different about this is that it does not handle it the same way as Git Bash do. In order to handle this, what you would have to say is git add dot, and then the next command is git rebase dash dash continue. And at this point, if you go back into Eclipse, you'll notice that the two have been merged back together again. And at this point, you can do it the same way as the previous demo. Just go ahead and remove where the first commit starts and the second commit ends. Save that, saying this is what I want. And then you can come in here and saying resolved merge. So resolved Windows changes. And then you can commit that. And then you can go ahead and now sync that back up to GitHub. And at this point, you can also close out this command line. So those are the only two commands that you would need to do. And we'll just wait for this to sync up. So now this is synced up. And then you can tell the other developers, hey, there was a merge conflict. Can you go ahead and do a pull? And everything should be fine. So he can do a git pull GitHub master. So now if he comes in here, you'll notice that the resolve commit gets pulled down and he now sees the changes, so both of the users are now in sync. At this point, you might be wondering why Git Bash behaves differently than the Windows client. That's a good question, so let's go ahead and recap what each client did. In our first demo, we were using Git Bash to resolve our merge conflicts. So what we did was we did a pull from GitHub. Git Bash gave us a merge conflict error. At this point, we were able to go into Eclipse, resolve the problem, and do another commit to save our changes. However, when we used the Windows client to resolve our merge conflict, it acted differently. In the Windows client, when we clicked on sync to get our changes from GitHub, it gave us a sync error and told us that we had to resolve it in the command line. Once we were in the command line, we had to type the commands git add dot, and then we typed the command git rebase -- continue in order to resolve it in Eclipse. Once we have resolved it in Eclipse, we did a commit to save our changes. In order to understand the differences, we're going to have to break down the flow of each client. In Git Bash, when you do the command git pull, pull is actually a helper command that does two git commands in sequence. It will do a git fetch, which will download the project from GitHub into a temporary branch. It then will try to do a git merge, so it will try to merge that temporary branch into the branch that you have stated when you did the command. In our case, we would always do master in our examples. The GitHub Windows client will also do a git fetch, but instead of doing git merge, it will do a git rebase. So what are the differences between git merge and git rebase? I will try to explain it in some demos. So let's go ahead and do a demo of fetch and merge. So I'm going to go ahead and do merge 1, and then I'm going to say dash Windows. Go ahead and save that. And then I'm going to say first change for Windows merge demo. Go ahead and commit that. And just to speed up the process, I'm just going to back out and go back in and then press sync again. While that's syncing up, I'm going to go over to the Linux one, and I'm going to make a change here too. So I'm also going to say merge 2, and then I'm going to say Linux, and I'll save that, and then I will do a git commit -a to add it to the staging area -m. I'm going to say merge 2 Linux. So come back here, it's in sync, so that means it's up on GitHub. So now what I'm going to do, instead of doing a git pull, what I'm going to do is do a git fetch GitHub. So right here, it gives me the small command that it did do a fetch from GitHub into master. So now what I'm going to do is a git merge GitHub /master. And right away, it gave me the same error that I would get when I did a git pull. It told me there was a conflict merge and that I would have to go and resolve it. So if I come in here, I would see the two conflicts. So here is my merge 2, which is my commit on the Linux box, which is the one I'm on, and here's the one for the Windows. So for this particular demo, I'm not going to erase anything. I'm just going to say example of fetch and merge, and then I'm going to save that, And then I will do another git commit -a -m, and I'm going to say resolved fetch and merge. And then I will do a git, just to do it properly, I would do a git pull GitHub master. I know it's up to date, but best practices. And then I would do a git push GitHub master. So that's pushed up to GitHub. Now, since this button is grayed out, I always have to hit the back button and then double click in, and then I can do a sync. So now if I come in here, I will see the changes. So let's go ahead and do an example of get rebase, or sorry, fetch rebase. So we can do rebase dash Windows. Well, let me add a 1. And then I'll save that. I can say rebase 1 demo of rebase, and then I'll commit that. So in here, in my Linux, I will do rebase 2, and then I will say Linux, and then I will save that, and then I will do another commit. Let me go ahead and start that sync, and then I will do a git commit -a -m, and I will say rebase 2 demo, and I've saved that. So let me go back in here. It's in sync, which means it's up on GitHub. I'll go ahead and do a git fetch GitHub, and there's the reply back that I did get something down from GitHub. So this time I'm going to do git rebase GitHub /master. And again, now my merge conflict is different, so I'm getting a different one. And what you see is that in order to continue, I would need to do git rebase -- continue. But before I do that command, I need to do git add dot, and then I can do git rebase -- continue, and then it will apply that commit. If I come in here, you'll notice that now I have my fetch and rebase change. So I'll go ahead and do this. So this would be an example of fetch and rebase. Go ahead and save that. Do a git pull GitHub master. Nothing has changed. Git pushed GitHub master. I went ahead and pushed my changes up, so now I can go back into my Windows user, go back, come back in, and now I'm doing another sync. And here are my changes. Whoops, I did not do a commit, did I? So let me do that real quick. Git commit -a -m resolved fetch and rebase, and then I will do a git pull GitHub master, and then a git push GitHub master. Alright, that got sent up. So again, I have to back out, double click in, and then I will do another sync. And this time I will see my comment field. So what are the differences that matter to you? What are the changes, when the rubber meets the road? What do you care about instead of all of the technical stuff? Well, if you take a look at fetch and merge, you see that merge 2 from Linux is here, and then merge 1 from Windows comes here. But if you look at rebase, the Windows one came in, and then the Linux one came in. Now we know that the Windows one was always committed first because I've always started at the Windows user. But only the rebase one cared about that. And that's where it's different. Is that when you use rebase cares about the order of things. And in order to do that, what Git people like to say is that it has to rewrite the history. In other words, in order to put things in order, it has to look at your history, go back to a place where they were both common, and then throw in the commits in that order. But in order to do that, you would have to rewrite the history for the Windows user, for the Linux user, and then save that rewritten history up onto GitHub. So that's really where the major difference is that you're going to see for as a developer. Now, does it matter in a 2-man group like I'm showing right here? Probably not. But, if you go into 8, 15-man groups, in which there's a lot of people that could change a particular file, does the order matter when the commits come in? It might. For me, I'm usually okay with just doing pull. Doing a fetch and merge works for me most of the time. Have I ever felt the need to use rebase yet? Not really, but it's something that you should understand. If you want to know more about fetch versus rebase, I've added some links below and you can go there to read up upon it, but this is about as far as I'm going to go when it comes to differences between these two. Also, if you're interested or if you want to know if there's going to be a helper command for fetch and rebase, there kind of is. We know that git pull will do a fetch and merge. Well, if you do a git pull -- rebase, what this will do is it will do a fetch and rebase. So this is the closest to a helper command that I know of. So we have talked a lot about how to resolve conflicts. So let's go ahead and switch gears and talk about how to prevent conflicts. So if you're a development team and you know multiple developers need to modify index.html, there are several things that you can do, you can plan for, or with a little discipline, you can prevent conflicts. So one way to do this is that at the very beginning of a development cycle, you can sit down and you can say, well, let's see, we both need to modify index.html. That is the Windows user and the Linux user. Let's go ahead and just mark down where we think roughly where we need to make our changes. So right away, what you can do is all you have to do is say, add comment field. So you can say Linux user, and then down here, you can say Windows user, right? You can go ahead and save that, and then we will do a git commit -a-m, and you can just say prep work. Then we can do a git pull GitHub master. Make sure that there's no changes up on GitHub. There isn't. And then I'll just do a git push GitHub master. So I'll go ahead and push those changes. Now keep in mind, I'm just adding comment fields, and this is done before the development cycle actually begins. So I'm just kind of marking down places in which, Git can use as reference points. So the Windows user, you just inform him, hey, I've marked down some things, can you go ahead and do a pull down? So back out, and then do a sync. Then we'll see these changes come in. So now if I go ahead and I do a change 1 Windows and I save this, so I just say new release Windows change. I can commit that, and then I'll go sync it back up. So over here, I will make a Linux change 1. I can save that. Then I can do a git commit -a-m Linux changes, and then I can do a git pull GitHub master, and these changes came down, and you'll notice that there's his changes and there was no conflict. And that's because just a simple thing as adding comments to be able to let Git use as reference points will prevent a conflict. So now I can go ahead and do a git push GitHub master. And then over here, I have to back out, come back in. And then I'll also do a sync. And there are his changes coming down. So there you go, you know. So these little small things that if you just plan it out ahead of time, you can actually prevent conflicts from happening. Or you can just be disciplined and say, you know what, I have other changes that I need to make. I'm just going to go ahead and let you change index.html. Tell me when you're done, and then I'll pull down your changes, and then I'll add my changes once you're done. So again, a little planning or a little discipline, and it goes a long way. Let's go on to our next subject, which is tagging. And tagging is the ability to save a specific point in history that is important to you. A good example of this would be when your software is ready for release. So it's ready for production, or it's ready to send to your users. So let's look at an example of how you can use tagging. So let's say in here, go ahead and select this. We are going to make our last change before we're ready to release this to our users. So we can just say footnote, and that is the last change. So we can do a git commit -a-m, and we'll say added footnote, and that is the last change we need to do. And since we already know this, what we're going to do is we're also going to do a git tag -a, which stands for annotation, and we're going to say version 1.0, and then we're going to say -m to leave a message. So you can say release version 1.0 ready, and then you can save that. And what we're going to do now is we're just going to go ahead and say made additional changes. So new changes. Go ahead and save that. Then we'll do a git commit -a-m. So we can say user enhancement. And then we also found a bug, so we're also going to say fixed bug. And there we go. We'll go ahead and save that. And then we'll do that commit again, and this time we said fixed a bug found in production. And when we fix that bug, we're actually going to do another release. So again, we're going to do another git tag -a, and then we're going to say version 1.1, and then in our message we can say release version 1.1 ready for production. And there we go. So in order to see these tags, all we need to do is say git tag, and right there we can see that there is version 1.1 and version 1.0. Now if you actually want to see some details to the tags, all you have to do is say git show v1.0, and it will show you everything that has changed during that. And you can download it. Scroll down and scroll up. So if you hit Shift ZZ, that will bring you out of that editor, and you can also do it for the other one. So you can say git show v1.1, and it would show you the other one. So let's go ahead and push these changes up to GitHub. So let's do a git pull first. Nothing has changed, and then we'll do a git push. So we went ahead and pushed all of that up to GitHub. Now let's go over here to our Windows user, and what we're going to do is we're going to back out, come back in, and we're going to go ahead and do a sync. And you'll notice that all of our changes have come down. That's great. Now there's no way that I know of in the Windows GUI to actually look at tags. You're going to have to go into your tools and open up the command shell. And then from here you can say git tag, and you'll notice that they didn't show up. You know, it's like, what's the deal? It's like, I've already pushed my changes up, but the tags didn't come up. And that's one of the strange things about git tag, or not strange, but the rules about tags. Tags by default do not get pushed up when you do a git push. You actually have to push them up individually. So let me show you an example of that. So in the command prompt, what we can do is we can do a git push GitHub, but instead of saying master like we usually do, we're actually going to push up a tag name. So we're going to say push up v1.0. And there, it's pushed up. So now if we go over here, we hit back, and then we double click again, it's going to refresh, and then it's going to say it's in sync, which means it's actually downloaded. So if we do a git tag again, you'll notice v1.0 is now over here. And now if we do a git show 1.0, we can also see everything that is involved in that commit. And again, Shift ZZ to get out of it. Now if we go back to our Linux, say we have a whole bunch of tags that we want to share, we don't want to just share one of them, well, you can do a git push GitHub, and then you can say --tag, and if you do that, it will push all of your tags up. So this time, if I come back to the Windows GUI and I hit back again and I double click, and again, this is one of the strange things, is that when you download tags, you actually don't have to hit this button. It'll just automatically do it. So this time, if I say git tag, I'll see version 1.0 and version 1.1. So if I git show v1.1, I can see the details to tag 1.1. Since the default behavior of tags is not to be shared with a remote repository, you can create tags that are only relevant to you. Keep in mind though, if you do decide to do this, you will not be able to use the --tag option anymore. Let's go ahead and move into our last subject of the day, and that's talking about how do we actually view our previous commits. And I'm not talking about viewing them in this diff window, but actually viewing it in your IDE or your development environment. And also, how do we actually go back to that commit if we need to. So in order to do this, in the Windows GUI, you actually can't do it. You're going to have to rely on the command shell once again. So once we open this up, let's say we want to go all the way back to prep work. So we want to go all the way back to this commit. So in order to do this, we need this hashtag right here, because this is what uniquely identifies the commit in Git. So I can quickly click here to say copy, and what I can do is I can say git checkout. Now we've used checkout before, but when we used checkout before, we used it in order to change branches. Now what we're going to do is we're going to use checkout to actually go to a commit. You can also use checkout to go to a tag, and we'll show that in a minute. So once you do that, you can say edit, paste. Now you don't need the entire hash. Actually, you only need about like that much of it, just enough so that Git can know which hashtag you're looking for. If you do this, it'll go to a commit, and what it'll do is it'll actually throw you off to a temporary branch. So in here, what you will see is now we've actually reverted back to that commit. We haven't changed anything. We've just moved to a temporary branch, and now we can show you what that at that point what your code looked like. So this is actually just moving back in time, but we haven't changed anything. So you can actually look at this code. If it was actually runnable code, then you can actually execute that code and see what it would do at that point in time for that commit. Now if you actually want to move back to where you were before, all you have to do is say git checkout, and then you would say master, and this would bring you all the way back to where you currently are. So your code would change, and this is bring you back all the way to the head, or at the very latest commit. Now we do have tags in here, so we have 2 tags. You can also do the same thing with tags. You can say git checkout v1.0, and again it will jump you to that tag. So the v.1.0 was when we added the footnote, so it jumped you to that tag. And again, if you want to go back to the latest, just go ahead and say git checkout master. This is just to be able to view a commit that you've already done. If you actually want to go back to that commit, then you're gonna have to use 2 keywords. It's either reset or revert, and they cover specific scenarios on why you will want to use one or the other. So let's go ahead and get into that. So in here, the GitHub Windows GUI actually does a pretty good job with this. So let's go ahead and quickly add some new commits. So let's go ahead and say new 1, save. So new 1, and then just say 1. We'll commit that, and then new 2. We'll save that, and then we'll say new 2. We'll commit that, and one last one before we start. So we'll do new 3. Go ahead and save that, and then we'll say new 3. So what we have here right now is we have 3 commits that we have not yet shared with our remote repository, which is GitHub. So these are all local changes. And when you have something like this scenario, and you want to revert back to say new 1, and you're right now on new 3, what you can do is you can use the rollback option, or if you use it in Git terms, this is the reset option. I'm not sure why they didn't use the word reset right here instead of going with rollback. So what rollback does is that it's going to change your history. It's going to rewrite your history, as Git people like to say it. Is that it's actually going to, if you want to go back to new 1, it's just going to erase new 3 and new 2 altogether. So it's going to completely wipe them out. And the reason why you can use reset, or rollback in this case, that's what it's called, is because you have not yet shared it with a remote repository. If you haven't shared it in any way, I'm talking about, through email, file share, whatever. If it's only been on your local box and you want to roll back to a previous commit, then you can use reset or rollback right here. And the reason for that is that we're actually changing the history. So you don't want 2 versions of a project with 2 different histories. This is why there's 2 ways for you to actually do a rollback or a revert to a previous commit. So let's go ahead. We're on new 3, so we want to go back to new 1. All you have to do is click that button, and all of a sudden you'll notice that we're on new 1 right now. And you can just go ahead and delete these, and then hit save, and then you can reapply new 1 again. So again, when you do a rollback, it just erases all of that history, and then you can just go ahead and wipe out all your changes that you want. But you can only do this if you actually have not shared it with any other application, GitHub, file share, email, whatever. It's only been on your local box. So let's look at the other option, which is revert. So before we do that, let's go ahead and add back in some commits. So we can say new 2, save that, and then we'll say new 2, we'll commit that, and then we'll say new 3, we'll save that, and then we'll do new 3, and we'll commit that. Except this time we're actually going to sync it, so we're actually going to share this with GitHub. So we're actually going to share it with our remote repository. So now once you've done that, once you've shared it, you don't ever want to use the rollback option. Instead, what you want to use is the revert option. And what the revert option does is that when you revert, it's just going to revert back your code, but it's going to save it as another commit. So let me just show you a demo of that. Now, the weird thing about revert is that if you do not want any conflicts, merge conflicts, you have to do it in sequential order. So if I want to get back to new 1, I first have to revert new 3. So I would revert that, and there's my revert. So it got rid of new 3. Then I can go to new 2, and I can revert that. So now I'm actually on new 1. So if I come in here, what you'll see is I am now in new 1. But in order for me to get to new 1, I had to go in sequential order to do the revert. So I had to start with 3, then I had to go to 2. If I actually want to go back to fix bug found in production, I can go ahead and do revert on new 1. So this is the important thing. If you don't want any file conflicts, you have to do it in sequential order when you use the revert. And this is actually named properly because the git command to use this is git revert. I don't know why they didn't say reset here somewhere. Instead they used rollback. They should have somehow fit that word in there without confusing some people. So you'll notice that also that these are actually only on my local box. So if you want to actually save it to the remote repository again, you would go ahead and do another sync, and these will go in as commits. So now let's take a look at what you need to do if you want to use the command line version instead of the GUI version, which, by the way, the GUI version does do a very good job. The only thing it doesn't explain very well is that in order to make it the easiest to do a revert, you have to do it in sequential order. Otherwise, you're going to get a lot of merge conflict errors. So let's go ahead and wake back up our Linux environment, and we will do our command lines here. So let's go ahead and on this side, we'll also do some new commits. Well, let's change the name. So and then we can do a git commit -a-m, say free 1. So we did that commit. Free 2. We did that commit. And then free 3. And then we'll do that commit. So at this point we have 3 commits down on our local box, and we want to go back to the first free 1 because we feel that we don't need free 2 or free 3 anymore. So what I would need to do is I would need to do a git log, and I would need the hash of free 1. So free 1, let's see, is right here. So let's see if I can copy this. So I can copy this, and then I'll hit Shift ZZ to get out. And what I'll do is I will say git reset, and then I will do -- hard. And then what I will say is, actually, did I copy the right one? I think it's actually this one. Let me make sure. So I'll copy that, and I'll paste it here, and I'll hit enter. So now I have reset to free 1. So if I come in here, you'll notice that free 2 and 3 free are now gone because I did a hard reset. And again, you would only do a reset, much like the rollback in Windows, when you haven't shared it with anybody else. So let's go ahead and add back in free 2 and free again. So let's see, that's 2. We added that back in. Oops. Had to hit save. And then do that commit. Probably should have changed the name. And then we do free 3. And then we once again do that. And then we'll save that commit. So let's just pretend that we actually did a push up to GitHub. I just don't want to spend the time to actually go do that. And all of a sudden we're like, you know what? We didn't need free 3, free 2, or even free 1. And I want to revert all the way back. But since I've already shared the code, I don't want to do a rollback or a reset. Instead, what I need to do is I need to do a revert. So let's go ahead and demo that. So the first thing we need to do is we need to do a git log and to get all of the commits. Once we know the commits, we can say git revert, and again this time we need to go in sequential order. So we would need the first one, and we would copy that, and then we need to paste it in here. Now if we want to get all the way to free 1, all we need to do is we don't need to do it in separate commands. We can actually copy this and then paste it in here and just use a space in between. And what this will do is it'll sequentially go ahead and revert back. So you go ahead and hit enter, and then you can say it's asking you for a note, so we can just put in, I should have said -m, and revert free and free 2. Okay, and then you can hit shift, let's see what it says, Control X, yes, and then oh, there's free 2. Okay, I guess I didn't need to add that in there. And then I can say Control X again and say yes. And now if I go back in here, it goes back to free 1. Let's do one more example of a revert, because I probably didn't explain the -m or the message very well, in which we're going to have to put in a message in order to do the revert. So let's go ahead and do, we're going to want to this time go ahead and revert back to free 1. So let's go ahead and do a git revert, and then we're going to take this hash right here. So we'll copy that, we'll paste that, oops, that's a copy, paste that in here, and we'll hit enter. So right now we are in the text editor, a command line text editor, and what it's asking me to do is to leave a message for this revert, and the standard message is right here, revert free 1, which is usually good enough, so there's nothing that we have to add. In order to exit this, what we have to press is Control X, and then once we do that, we'll come in here and you'll notice free 1 is now gone because we reverted that out of it. So just keep that in mind, is that once you do a revert in the command line, it might throw you into a text editor, and all it's asking you to do is leave a message, and you just gotta exit out of it and everything will be fine. Here are my final thoughts. For whatever reason, the web has embraced Git, and that makes it an important technology to learn. If you look at the modern world, almost everything we do or everything we get is connected to the internet. So as developers, even if you don't use Git every day in your job, it's still an important skill to learn. As for the Windows GUI, I think it's great for small projects or solo projects. At least that's what I use it for. One of the benefits that I really like from using the Git Windows GUI is that it self-updates. So anytime a Git version control, the actual client itself, updates, Git Windows will actually update that for me. The only problem is that Git Windows hides too much, and it's really not a good tool to learn or a good tool to use when you're trying to learn the Git version control system. As for Git Bash, I think everybody needs to learn at least the basics to Git Bash, because even if you use the Windows GUI, you will end up every once in a while having to go back to the command line in order to do something. I personally don't use it as the main client for how I interact with Git the version control system. Instead, I actually use TortoiseGit, and I already have a video of this up, and it is my preferred method when I'm using Windows. Now generally if I have to use Linux, then I just go ahead and use the command line version. It's just the easiest thing. And the Mac also has a version of the GitHub Windows GUI type. It's called like GitHub Mac or something like that. And it's also equally as good compared to GitHub Windows. Congratulations, you have made it to the end of this video series. Thank you very much for your time, and to my subscribers, thank you for your support.